Hello students, today we will see one topic in quantum mechanics. We are going to discuss how de Broglie with his wave hypothesis give justification for one of the Bohr's postulate. This is how we are going to discuss in this class. See, we know according to de Broglie hypothesis, matter is associated with wave. See, just like a light behaves sometimes as a particle, sometimes as a wave, just like that matter is also having particle and wave nature, dual nature. So this is the de Broglie hypothesis, and we have seen it in previous class, the detailed de Broglie hypothesis. Now we will see how de Broglie justifies the Bohr postulate. See, Bohr actually given an atomic model with three important postulates. Those postulates are, for the most of the time, they are there without any theoretical justification. So after that, de Broglie with his hypothesis of matter waves concluded that he will provide the justification of one of the Bohr postulate, which states that the angular momentum of a revolving electron in a circular orbit is quantized. So this Bohr postulate is justified by de Broglie with his matter wave hypothesis. See, angular momentum L is equal to nh bar. This is the Bohr postulate, where L is the angular momentum of the electron. See, in de Broglie hypothesis, see, even electron or any microparticle or any matter is associated with matter waves. Suppose an electron is revolving in an orbit, in a circular orbit. So he says, de Broglie says that the electron should revolve in the orbit just like it follows its own path and meets itself in the circular orbit. So again and again, if it does not meet itself in the circular orbit, that means the wave is out of phase. If the wave is out of phase, so it means that it is revolving in different orbits, and thereby it is also having different phases. So it causes the electron to lose energy, and because of the destructive interference of the electron wave, it may annihilate and lose its energy. But actually it is not happening. What happening is, electron is stably revolving in the electron orbit. For that he said that electron will be revolving in the orbit and it will meet itself by doing circular orbit revolution. Okay, so that means we can say that the electron is having a standing wave profile while revolving in the electron orbit. So to prevent the preclusion of energy radiating away and the destruction of electron, so it prevents itself by revolving in the orbit in like a orbital nature. Okay, so here this Bohr postulate is directly came from the de Broglie hypothesis. Okay, see, we know what is a standing wave. What is a standing wave? When a string is stretched between two ends, the standing waves are formed because of the overlap of the progressive waves. So here the standing waves formed, or the wavelength of standing waves formed, is half integral multiples of the wavelengths of the disturbance. So if the string is considered as a loop, circular loop, so in this case the wavelength of the revolving electron is integral multiples of the full wavelength of the matter waves, that is electron waves. So in this way, that angular momentum is with this postulate, we know that the de Broglie wavelength is equal to lambda is equal to h by mv. Okay. See, if it is a circular loop like a circular orbit, so we can say that according to de Broglie hypothesis, the circumference of the orbit is integral multiples of the wavelength, full wavelength of the electron. So that we can write it as the circumference of the circle as 2 pi r is equal to n lambda. So perimeter is equal to integral multiples of the wavelength of the electron. So here we know that by de Broglie hypothesis, lambda is equal to h by mv. So here we, in this equation we put lambda is equal to h by mv. Okay. So if we take mv this side, we may write mvr is equal to n h by 2 pi. See, mvr we know is equal to angular momentum of the revolving electron. So this is the angular momentum, and we can write angular momentum represented with L, and n h by 2 pi we can write h bar. So this is the Bohr postulate coming from the de Broglie hypothesis. Okay. So in this way he concluded that the electron revolving in an orbit will be having the integral multiples of its wavelength fitting into the circumference of the orbit. Okay. So by concluding this, we take an example how to calculate the de Broglie wavelength in a revolving orbit. Okay, for an electron. Consider in hydrogen atom we calculate the wavelength of electron in first orbit of hydrogen atom. Okay. See, here these two diagrams will represent the revolving electron in a circular orbit, right? If this is the nucleus, this is the revolving electron. See, this follows itself and meets itself again and again in the perimeter of the circular orbit. In this diagram we can see if n is equal to 3, that means quantum number n is equal to 3 and this is n is equal to 5. See, the wavelengths is n multiples of the perimeter. That's why we have written in this formula 2 pi r is equal to n lambda. The wavelength full multiples of the quantum number is equal to perimeter. So the number of waves will fit into the perimeter. Okay. So here in the next step we will see how the de Broglie wavelength will be calculated and how it will justifies the Bohr postulate. Okay. See, we know that the velocity of the electron in a orbit is equal to, we can write 4 pi epsilon naught into mr. Here electronic charge and mass of the electron, radius of the orbit. Okay. We know that from de Broglie hypothesis lambda is equal to h by mv. That implies we can write v is equal to, so m lambda by h is equal to 1 by v, right? So that implies v is equal to h by m lambda, right? Velocity is equal to h by m lambda. So you put v in this equation. What is v? H by m lambda is equal to E by root of 4 pi epsilon naught m into r. So what will be lambda here? We need to find the wavelength of electron in moving in first orbit of hydrogen atom. So lambda will become, it goes to the numerator 4 pi epsilon naught mr, okay. So it becomes to the numerator and m h, okay, by E. So m lambda, or we can write in the reverse form. First we translate the numerator and denominator, then we will find. By E. Now take lambda. So lambda is equal to h into 4 pi epsilon naught mr by me, right? So here we can write this m into the root and the electronic charge. With this formula we can find the wavelength of the radius of the wavelength of the electron wave in the first orbit. So if we take r as radius of the orbit as 10 to the power 5.3 into 10 to the power of minus 11 meters. We know that the radius of the Bohr orbit, first orbit, is 5.3 into 10 to the power of minus 11 meters. So if we put this value in place of r, radius of the orbit, and we calculate lambda, the lambda will be coming as 3.3 into 10 to the power of minus 11 meters. Okay. So here the perimeter of the Bohr orbit will also be calculated in this way, and it will also be coming as 3.3. Actually this is not 10 to the power of minus 11, this is 3.3 angstrom units, and this will also be coming as 3.3 angstrom units. So here if we observe, the wavelength of electron in the first orbit is equal to the perimeter circumference of the first Bohr orbit. So this is what the de Broglie hypothesis said in a wave profile, that if a electron wave can form a standing wave in a circular loop like orbit, so it will not radiate the energy away and it will not annihilate, and it does not cause the destruction of the electron. So the electron stably can revolve in the electron. So this justifies the lambda and the perimeter is equal. So in this way, by this we can say one wave of the electron will be fit into the first Bohr orbit, and it meets itself while revolving in the orbit. So this is the hypothesis of de Broglie, which has justified the Bohr postulate of quantization of angular momentum. So by this we conclude that, saying that electron is considered in two ways: either a moving particle with quantized angular momentum, or a particle having a matter wave which fits into the circumference of the orbit, or the waves associated with the electrons are integral multiples of the wavelength of the electron. Okay, the circumference is integral multiple of the wavelength of the full wavelength of the electron. So in this way the electron can be taken in two ways by de Broglie. So this is how we have taken the justification. Okay, see, in the next class we will see some more applications of de Broglie's hypothesis.